Okay, so today we are going to discuss about stepped or cone pulley headstock. First of all, in this drive, there is a uh, input shaft is rotating with some constant RPM. So input shaft RPM is N0, which is constant, right? And from this input shaft, we get variation in the output, variation in the RPM. So different RPMs we get on the output shaft. So on output shaft, we get from N1 to NZ RPM, where Z stands for number of speeds, where Z is equals to numbers of speeds, right? So to achieve that, we are using cone pulley drive. So on input and output shaft, on input and output shaft, we use cone pulley, right? So let me show you diagram of cone pulley. So suppose we are talking about 5 number of speed steps, then suppose this is pulley 1, then we use on another pulley. This is pulley 2, and then we use one third pulley. Right now, suppose we are taking example of only 3 pulleys, then let me call this is pulley 2 and this is pulley 3, and this is the shaft axis, right? So the diameters of input pulley, that is capital D1, diameter of output pulley is pulley 2 is that D2, and diameter D3. So these are the 3 pulleys on input shaft. Now as this is connected to motor and motor is running with some constant RPM, let me call that constant RPM as N0, right? And opposite to that, now we'll be having output pulley, which is also having same number of steps. So here, this is pulley D3. Let me call diameter of this pulley is small d3. Then we have second pulley with diameter small d2, and then we have third pulley and diameter of this is d1, right? So these pulleys, they are on output shaft. So these pulleys are on output shaft, and to transmit power we are using build, and right now we are assuming build is between pulley 2 d2 and small d2 diameter, right? And then we are getting transmission of power with the help of build. So we have build here. So we are transmitting power through build, right? But the condition is what? Here, same build is to be used for power transmission between these two pulleys, means capital D1 and small d1, capital D2 and small d2, and capital D3 and small d3. Same diameter is to be used, right? Now, if you look here, because of this diameter difference on input shaft and output shaft, we are getting variation in this speed, right? So let me make a list of parameters where I say N0 is speed of driving shaft speed, right? Then from N1 to Nz, speed of output shaft. So N1 to Nz, that is driven shaft speed. Driven shaft speed, right? Then if we see the diameter, then capital D is used for diameter of driving shaft. So capital D 1 to, if you are talking about Z number of speed, then D1 to DZ is equals to diameter of driving pulley, right? Similarly, if we use small letters, then small d1 to small dz is diameter of driven pulleys on driven shaft, right? So this is our driven shaft. This is our driven shaft, right? So by changing build from this 1 1 1 to pulley 2 2, we get variation in the speed, right? Now let me write speed ratio. Then if you consider speed ratios, then speed ratio is equals to, for first speed, we can say N1 means the speed ratio is nothing but transmission ratio, right? So speed on output shaft from input shaft, if you are using pulley 1, then N1 by N0 is equals to, in case of build drive, it is nothing but diameter ratio, right? So I can say input shaft diameter to output shaft diameter. This is for step 1, means if you are using pulley 1, then you get here step 1, then for that we have this speed ratio or transmission ratio, right? Now if you talk about step 2, then for step 2 again we get here N2 from N1, sorry, N0, because driving shaft is constant, speed of driving shaft is constant, that is N0, and here diameter ratio will be D2 by small d2. Please remember this capital letters, that is for input shaft pulley diameter, right? So both are inversely proportional. Then similarly, if we go for step, likewise if we reach to step, last step, Z step, then here we get N Z means the maximum possible RPM from the head stroke or from the gearbox to N0 input RPM is equals to dz by small dz, right? So this is what the speed ratio or the transmission ratios. Now if our condition is length of build is same for all these pulleys, then length of build remains constant. So length of build. So equation of length of build is what? It is suppose a straight build drive, then it's a pi. If we are talking about first step, then d1 plus small d1 divided by 2 plus d1 minus small d1 whole square divided by 4c, where capital C is center distance between driving and driven shaft. Now this is length of build. Now as per the condition, same build is to be used for all the pulleys combination. So this is the length of build for first pulley combination. Then length of build for second combination will be pi d2 plus small d2 divided by 2 plus capital D2 minus D2 square, same as above 4C, right? But the condition is same build is to be used. Then length of build is same. Then this equation, if we equate, then if you look the previous page, then here we have one relation in terms of diameter ratio and speed ratio, and here on the next page we have second relation of build diameter. So if you finalize what should be the center distance between two pulleys or two shafts, driving shaft and driven shaft, then based on this equation and this previous equation of speed ratio, we can find out both the diameters, capital D1 and small d1. Likewise, you can also find out capital D2 and small, sorry, here I have made one mistake. This will be 2 here, right? So using these two equation, this speed ratio equation and this length of build equation, you can easily find out diameters of pulley, right? But here the change is these speeds are to be, if you look here, this n1, n2 and up to nz, this speed should be in geometric progression, right? Because we are going to design gearbox for machine tool application. Then in case of machine tools, if we use geometric progression, then we get a proper speed steps which can give us less loss in economical speed. So with that consideration, we cannot select any random speeds from n1 to nz. So that's why n1 to nz should be in geometric progression. So with that assumption, now we will do some modification in simple cone pulley drive, because we want cone pulley drive for gearbox, right? For machine tool gearbox. So we can say this n2 by n1 should be in some geometric progression. Similarly, n3 by n2, and likewise same geometric progression for nz to nz minus 1, right? So this is what the requirement. So we are now considering this condition in deciding diameters of pulley so that we get speed in geometric progression, right? So now if we do that, then let us write this in terms of diameter ratios, this speed ratios in terms of geometric progression constant and diameter ratio. Then we can say n2 is equals to phi n1. Similarly, n3 is equals to phi n2, and we reach up to nz. Then this is what the general about geometric progression series which we have already learned. So this is phi raised to z minus 1 into n1, right? This is this equation we have already used. Now let me write this in terms of diameter ratio. Then to achieve n1, this n1 by n0 is input shaft RPM, is equals to first set of pulley diameter ratio, then this will be d1 by small d1, right? Okay, so here what I can say this n1 is equals to n0 times diameter ratio. Fine, but this n2 by n1, or I can say now next speed should be in geometric progression with the previous speed, right? So the modification is I need to write now this n2 is equals to phi and n1 from this. right? So phi into capital D1 by small d1 into n0, right? If you likewise, if you find for n3, if you find same for next RPM means n3, then n3 will be phi square into d1 by small d1 into n0, right? Now, similarly, if I want to write for nz, means the last speed, then this equation, if you look here, n3 is equals to phi raised to 2. Then nz will be phi raised to z minus 1 into input pulley diameter ratio into n0. I hope this equation is clear. So nz is equals to phi, which is geometric progression constant, raised to z minus 1 into capital D1 by small d1, n is equals to n0. Right? Now here, if you look, let me take new page. So if you now look, this nz by n0 is equals to phi z minus 1 into diameter ratio, input pulley diameter ratio, first set of pulley. Then this I can write in terms of pulley diameter. Nz by n0 is what? I can write this dz by small dz is equals to phi z minus 1 into d1 by small d1. Is it fine? So this speed ratio here, this speed ratio is written in terms of pulley diameter ratios, right? But the next consideration is, if you look here, generally in this pulley, this first pulley, if you are talking about three pulleys, then this large pulley is equals to large pulley given on driven shaft. Means capital D1, means if I mention here, then capital D1 is equals to small d3. Similarly, capital D2 is equals to small d2, and capital D3 is actually equals to small d1. So both pulleys are ideal, only they are flipped. That is what the design criteria of step cone pulley drive, right? So with that criteria, if we try to introduce that same here, if you try to introduce here, then I should say dz is nothing but small d1. We can say that. Similarly, this small dz, I can say capital D1. I hope it is clear. So if we do that, then on this side, we'll have this large dz is replaced by d1. Then here, what we'll get finally? We'll get d1 square by capital D1 square is equals to phi raised to z minus 1. I hope it is clear, right? Then if we remove square, and if we want to write this in terms of diameter ratio only, then this small d1 by capital D1 is equals to phi to the power z minus 1 by 2. I hope it is clear. So this is what we got, diameter ratio with two conditions. Diameter ratio with the two conditions if we want speeds in geometric progression and we are using both the pulleys as an ideal pulley, right? But this small d1 is the output shaft pulley diameter and capital D1, that is input shaft pulley diameter, then this ratio is actually indicating inverse of transmission ratio, right? So if I want to write this again, I want to write this in terms of transmission ratio, then U1 is our transmission ratio for first set of pulley, then this is actually equals to N1 by N0. And here, if you look on this page, this is inverse of, this is nothing but 1 by U, 1 by U1, right? So if I take U1, then I need to write this 1 by this entire term, phi raised to z minus 1 by 2, right? So let us do here. So this U1 is equals to n by n0, then I need to write this as 1 by phi raised to z minus 1 by 2, right? So similarly now, next if I want to write transmission ratio for second set of pulley, then this is nothing but N2 by N0. Then I need to write here N2. Now I am multiplying and dividing by N1. So N1 by N0, then there is no change in the equation. But what N2 by N1 represents? That represents geometric constant phi. So here we get phi into N1 by N0, that is already we got here. So that is 1 by phi z minus 1 by 2. Then finally I can say U2 is how, similarly now suppose if I want to write it for U3, then same here, what I need to consider? I need to consider N3 divide by N1, N2 into N2 divide by N1 into N1 divide by N0. Then what we'll get here? We'll get here phi square 1 by phi z minus 1 by 2, right? So similarly now, suppose if I want to write it for some intermediate speed, right? So suppose Uj, that is transmission ratio for a set of pulley which is in between pulley 1 to pulley Z. Then I should say here phi 1 power less, then I say here it is j minus 1. So phi j minus 1 into, or I should say now directly, this is divided by phi to the power z minus 1 by 2, right? So if you simplify this, then what we get transmission ratio for intermediate speed step is equals to phi, just take j minus 1 minus z minus 1 by 2 as a power of phi. Then what we'll get? We get here 2j minus z plus 1 by 2. Fine. So this is what we got, equation for intermediate speed, any intermediate speed uj. Now similarly now if I want to write transmission ratio for maximum possible speed, which is nothing but u Z, then this equals to what we'll get here? Phi to the power Z minus 1 into, or directly I say it's a phi Z minus 1 by 2. Z minus 1 by 2. Then what we'll get here? We will get here phi to the power Z minus 1 by 2. Right? So this is for uz, and this is nothing but equals to output speed to input speed ratio. So output speed is maximum possible speed nz divided by input speed is constant, which is n0. Means it is a motor speed if you directly couple gearbox with the motor shaft, right? So this is what we got finally. So in general equation, I would say uj is our general equation, which is phi raised to 2j minus z plus 1 by 2, right? Now let us try to draw speed diagram using this. So suppose if we are assuming how many speeds we want, suppose we want total 5 speeds using cone pulley drive, then z is equals to 5. Then please will you revert back in the chat how many set of pulleys are required if 5 speeds we want? Then please quickly revert back in the chat. If we want 5 speeds, then how many? Yes, so we require 5 pairs, right? So if we require 5 pairs, then as those 5, both the pulleys are of ideal type, right? So now if using this equation I would try to understand what will be the ray diagram or the speed chart of this cone pulley drive type of gearbox, then let me call this is my input shaft speed line. This is my input shaft. This indicates input shaft. And how many speeds I want? I want total 5 speeds. Z is equals to 5, right? So I draw here 5 vertical lines. 1, 2, 3, 4, and 5, right? And now suppose now I just okay, fine. Now, so this is what my input shaft. So input shaft is running at constant RPM, which is N0, right? And on output shaft, I am getting 5 different RPMs. So let me call this is N1, this line is N2, this line is N3, this line is N4, and this line is N5. What I have done here, I have just changed the orientation. In the previous all gear type of gearbox or sliding cluster type of gearbox, we have drawn this speed lines as a horizontal and shafts as a vertical. But here I have drawn shafts as a horizontal and speed lines as a vertical. So that is the only change. So this is this first horizontal line on top, that is called as a input shaft, and this is called as a output shaft, right? And this lines they are indicating speed. So now let me check what will be the and each line is having geometric progression of phi, right? So each line is having geometric progression of 1 phi. I call this as phi, right? So now if I want to check what will be the what will be the transmission ratio progression between n1 to n0, right? What will be the n1 to n0? Then this equals to, we are talking about first step. So here in this equation, we are talking about u1, right? So in this uj equation, just put j is equals to 1 and z is equals to 5. Then how much value you are getting? Please will you revert back in the chat, 5 to the power, how much you are getting? If you put j is equals to 1 and z is equals to 5, then how much is the power of 5? 1 minus 6. So minus 4 divided by 2. Then it's a minus 2, right? So here we get 5 to the power minus 2. Means it's a 1 by 5 is to 2, right? Similarly, suppose what is n2 by n0? What you will get? Again now 2 into 3, 6. 6 minus, sorry, we are talking about second speed. So 2 into 2, then that is 4. 4 minus 6, then it's a minus 2. Minus 2 by 2, then it's a minus 1. So we get here 5 to the power minus 1, right? Similarly now, if we want to find out n3 by n0, then n3 by n0, then put j is equals to 3, then what you get? 2 into 3, then 6. 6 minus 6 by 2, then we get 5 to the power 0, then that is 1, right? Similarly, now next is n4 by n0, then is equals to n4. How much? Then 4 into 2, 8. 8 minus 6, then 2. Then 2 by 2, that is positive 1. So 5 to the power, here we get 5 to the power 1. Similarly, now last transmission ratio, which is n5 by n0, is equals to what we'll get? We'll get 5 is to 2. Right? So if we draw speed lines, then simply what we can say, this n is nothing but mean of 2 actually. So this n0 is generally square root n1 into n2, right? This is what the n, because these lines, they are indicating log 5 actually. We are writing here for our understanding it is 5, but this line on linear scale, they are indicating log 5, right? So if you draw n0 to n1 line, then how much is the progression? We are getting speed reduction. Then I need to draw this to this. Then this, I can say this line is indicating motor RPM, which is n0, right? So this indicates motor RPM. Similarly now, from n1, from same speed, what we are getting next speed is n2. So drop in the geometric progression 5 is to 1. So that's why I draw one another line which gives us n2. Now from n0 to n3, third set of pulley, that is giving us same speed n0 to n3 as per this transmission ratio equation. Now as per this transmission ratio equation, n4 is having geometric progression of 5 is to 1 with respect to n0. Then we draw a line here. Similarly, n5 is 5 is to 2 progression with respect to n0. So this is what we can say, ray diagram of cone pulley type of gearbox. I hope it is clear. right? So you are advised to draw ray diagram for z is equals to 6. Try to draw ray diagram for z is equals to 6. What you will get, just check. Now if you have any doubt in today's session, then discussion is open. Now you can ask your queries.
Sir,
Yes.
sir, this equation n0 equals to root of n1 and 2, how did we derive it?
See, generally, let me take one new page. See, if you draw this, if you if you just simply use these equations, then you get this diagram. Is it clear? You get this diagram. This speed chart is clear.
Yes, sir.
Okay. So looking to this speed chart, as I told you, this vertical lines, they are indicating actually log phi, right? So what I can say, log n0 is mean of n1 to n5 or mean of n2 to n4. Is it right? It is mean of these two speeds, any two speeds.
Yes, sir.
Yeah. So if you do that, then log, now I'm taking log, then log n0 is nothing but representing log n1 plus log nz, suppose if you are talking about z number of speeds, divided by 2,
Yes, sir.
right? So now if you are taking log, then what we can say, this if you do cross multiplication, then 2 into log n is equals to log n1 plus log nz.
Okay, sir. Got it. Got it.
Yeah, so that is n square is equals to n1 into nz. So now if you take square root, then we get, sorry, this is n0, this is n0. So n0 is equals to square root n1 into nz. So what ultimately this is telling us, this tells us what should be the motor speed actually, if you want n1 to nz speed. Is it correct? So suppose your specification of gearbox are final, means suppose you know about range ratio, right? If you know about range ratio, which is nz to n1, this is our first step. Whenever we start design of gearbox, then we need to first of all select range ratio. So if range ratio is final, if nz and n1 value is final, then what should be the speed of motor shaft, or what should be the input speed of gearbox, right? That we can find out from this relation.